Hi guys, in question 8 we're asked to factorise this. Now it's a pretty nasty thing to be asked to factorise, but my advice is if you get something like this, get the like terms. Well, when I say like terms, there aren't any like terms, but get the terms with something similar together. So you can see I've taken these two and I've written those two together because they've both got an x in it. If I do the same here, you'll find that you may know that alternative method for factorising when there's a coefficient of x squared. This is going to turn out very similar to that. So let's look at these first two terms. Okay, so we've got a 4x in both. So let's take that out and factorise for it. So we're going to have that. Let's do the same thing for these two terms here. So we could take out a minus y. That would give me y plus 1. And this should now look a little bit familiar for you. You factorised, you have this repeated bracket, and you can say that this is exactly the same thing. Because you've got 4x lots of this bracket and minus y lots of that bracket, you can combine them to look like this. And if you were to expand that to check, you find that you get this answer. Okay, so this question, they're being nice to you, to be honest. They don't have to give you this part A. They could go straight in with this part B and you'd be expected to solve it. And you can see what they've done. So they've said this here, sine theta cos theta. Well, they're different, so they've called that xy. You've got cos squared theta. They used a y for there, so they're using a y squared there. You need to make the connection between these two. They're not going to ask you to do something like that if you're not intending on using it here. So if we take this and actually just swap the x's and the y's around, we factorised it already. And if we're going to solve it, we're going to have to factorise. So 4 sine theta cos theta, let's make our brackets pretty big here. We know it's going to be 4 x's, and they've used x to be sine, so it's going to be 4 sine. Then we're going to take away y, and y is cos theta. Then in this bracket it's going to be y again, so that's going to be cos theta plus 1. Now let's just check this to make sure we haven't made any mistakes. So 4 sine cos theta, check. 4 sine theta, that's there. Minus cos squared theta. And we've got a minus a cos theta. So that is all equal to 0. So if you couldn't see what I was doing there, probably because I didn't draw any lines, but I just expanded those brackets in my head just to make sure I got all of this. Right, so just like all the factorising you've ever done when you're solving quadratics, we can say that this left-hand bracket, that should have a theta there, 4 sine theta minus cos theta is equal to 0. And we also have this one here, cos theta plus 1 is equal to 0. Let's start with this one on the right because it's very simple. So cos theta is equal to minus 1. I don't use my cast here. I know a lot of people do, but I like to think of my trig graph here. Now this is the range 0 to 360, so we know it looks like that. And we know this value here is minus 1, and we know that this angle here is 200. No, it's not. It's 180. Okay, so theta is 180 degrees. That's going to be one of our answers. Let's see what happens here. This one's a little bit harder. This one, I've got to try and solve it, but I've got mixed trig ratios. So we need to try and make that 1. Now, if I divide everything by cos theta, I'll do this like this. When you've got sine and cos, always think about doing this because you know that tan theta is sine theta divided by cos theta. So that's 4 tan theta minus 1 because they will cancel each other out, and that's equal to 0. So we can say that 4 tan theta is equal to 1, therefore tan theta is equal to a quarter. Right, so now we have to think about using our cast diagram. I'll draw it over here. So there we go, let's make that a bit longer. C-A-S-T. Now where is tan positive? Well, tan is positive in this quadrant and this quadrant. So draw your angles from the horizontals. It's between 0 and 360, so we're going to go from 0 in this anti-clockwise direction all the way around till we get to 360. So we're going to have a solution here, and we're going to have a solution there. Okay, so now we have to use our calculators, and let's work out what theta is. So it's going to be the inverse of tan of a quarter, and that actually gives us 14. So I don't have a calculator, I have to check my notes. So that's 14. Okay, so therefore we know this is 14, but this angle here is also 14. This is what this means. So 180 plus 14 is 194. Okay, so let's finish up by writing all three of these in ascending order. So theta is going to equal 14, 180, and 194. And just a good habit to get into, I wish I didn't underline those actually, but I like to underline the 14 in the same colour as I did on my line here. So on my exam I'd be using lots of colours. I just think it helps with my working out. Okay, so there's your answer.